Welcome to our notes on 2-7. We are in Unit 2. Unit 2 is an extension of Unit 1. In Unit 2, we started off talking about mixtures, more specifically the types of mixtures and properties and characteristics of those mixtures. We also mentioned in Unit 2 that we will be talking about states of matter. We introduced states of matter in Unit 1 when we said that what state of matter a particular substance is at a given temperature and pressure is a physical property of that substance. Physical properties are those properties that you can observe without actually doing anything chemically to the substance. And in this unit, 2-7, in these particular notes, we're going to be taking a look at the types of states of matter, and we're going to be looking at the energy changes that accompany phase changes or states of matter changes. What is a change of state as we're beginning into these notes? A change of state is when a matter changes from one state to another. Again, this is a physical change because when something goes from one state to another, it is still the same substance. So you could have ice. Ice is frozen water, water in the solid state. If that ice melts, it can change into a liquid. It's still water. Energy can be given to that liquid, and you can get that liquid to evaporate or even reach its boiling point and begin to vaporize. And when you're done, you have water vapor. All three of those states are still water. You haven't changed what substance is there. When a substance changes into another substance, that involves a chemical change. And states of matter, once again, are physical changes. For the subject of chemistry, introductory chemistry, we want to recognize 4 states of matter. There are far more than 4 states of matter, which you'll learn as you progress into science at a greater depth. There are all kinds of crazy, exotic states of matter that really are beyond the scope of a Chemistry 1 class. Many of you know these 4 states of matter already. You'll have the opportunity, if you wish, when we get into the videos on states of matter, I will give you some suggestions of videos that you could watch if you want to look into the additional states of matter that won't be discussed. So if this is something that interests you, there are all kinds of videos out there that you can watch if you want to get into all the funky states of matter. But what are the states of matter that we need for an introductory chemistry class? Obviously, you've heard of the state of matter that we call solids. Solids are recognized by having a definite volume as well as a definite shape. There are all kinds of specific subcategories of solids. For Chem 1, we really do not need to take a look at the different subcategories of Chem 1 in Unit 2, but we can take a look at a few of those now, just so that you know there are different types of solids. One commonly used classification of solids are whether the solid's considered a crystalline solid or an amorphous solid. Crystalline solids are very common and ones that most people identify as being solids. Their shape is definite and they have a geometrical shape to them. In other words, it is a regularly shaped object. Crystalline solids tend to melt at a specific temperature. And when you cut crystalline solids, they tend to break apart into pieces that have neat and smooth lines. When you go to melt a crystalline solid, they have a specific heat that would be required to melt them, and that's called the heat of fusion. They are kind of considered to be what we would commonly call true solids. There are also solids that are considered amorphous. Amorphous, the word amorphous means without shape. So these are solids that tend to have an irregular shape. They can soften over a wide range of temperatures. So, with a crystalline solid, they are solid and they stay a solid, but if you get them to a certain temperature, you melt them into a liquid. An amorphous solid kind of has that in-between characteristic where they soften over a range of temperatures. When you cut amorphous solids, they tend to cut into irregularly shaped surfaces. And they will begin to melt over a range of temperatures. Some people consider them to be pseudosolids. Liquids, however, have a definite volume, but they have an indefinite shape. We know that liquids will take the shape of their containers. So when you have a liquid in whatever container you have it in, that's the shape that the liquid will take. Gases have an indefinite volume and an indefinite shape. The volume of a gas, we know gases will expand and spread out to fill their container, because the particles in gas are randomly spreading about, moving from areas of high concentration to areas of low concentration. That process is called diffusion. Now, both liquids and gases are capable of flowing. We know liquids can flow. Their resistance to flowing is called viscosity. Gases flow very easily. Any state of matter which is capable of flowing is considered to be a fluid. Any state of matter capable of flowing. The truth be told, amorphous solids over time can flow as well, but solids in general are not considered to be fluids. A fourth state of matter that we deal with in chemistry is plasma. Plasma is a high temperature physical state of matter where the atoms begin to lose electrons. Electrons can fly off the atoms, leaving ions behind, charged atoms. So the fourth state of matter in chemistry is plasma, and this is the highest energy state that we tend to deal with on a common basis in Chem 1. What are some of those weird, exotic states of matter? Let's take a look at some of those. Looking at the states of matter in a more modern approach, we have the low energy states of matter. The classical states of matter are considered part of these, the solids, liquids, and gases. We have the high energy states of matter on this side, the plasmas. And if you take a look at modern classifications, there are a bunch of these different states of matter that are now known to exist. And these are beyond the scope of a Chem 1 class right now, but I just wanted you to realize that the methods now and approach to classifying states of matter as we get deeper into science are certainly broader than we want to keep in the simplistic form. If we're looking at the universe, which of the states of matter is believed to be the most common one? It would be plasma. About 99% of our universe is believed to be made up of plasma, as that is the state of matter found within the stars. On the Earth, where do we have plasma? And the answer there would be like neon lights and so forth, which have electricity going through gas, providing enough energy to actually knock the electrons off the gas atoms, creating plasma. Here's a little picture of the states of matter. In general, we consider the solids to be this regularly repeating pattern, everything lined up in this nice shape. That's how we picture solids. Amorphous solids, it's just not going to be arranged quite as neatly. When you add energy to this solid, these atoms begin moving apart, and then eventually, if we add enough energy, we can overcome the forces that were keeping them in place, which would allow those atoms then to move amongst each other and around each other, and that's what a liquid is. In a liquid, the molecules are allowed to flow around each other. They're still held together. We haven't added enough energy to pull the molecules or atoms in the liquid apart. So here they're locked into place. We add enough energy, now they're able to move. If we add more energy still, the liquid molecules, the forces that are holding the liquid molecules together can be overcome. And in that case, they can actually fly out of the liquid, and that's what a gas is, where we add enough energy where now the particles are able to fly away from each other and move randomly about. To get a plasma, we have these gas molecules or atoms flying apart, and we add enough energy where the electrons will begin to flow off the atoms. So that's what these negatives are, the electrons flowing away from the atoms, and we are then left with the positive stuff behind there, and that's what a plasma is. I kind of picture it sort of like airplanes on the runway. Here we have the airplanes all lined up. They're not moving very far. They might just be moving a little bit in place. When we add energy, the airplanes are now able to flow down the runway or move down the runway. If we add enough energy, the airplanes can take off and be now traveling freely and randomly out into the atmosphere. That would be a gas. I don't want to use the analogy of what happens when we get plasma. That little analogy wouldn't work too well because there we'd have so much energy that parts of the plane would fly off. We don't quite want to go there. When we're looking at descriptions of matter, for a given substance, solids have the lowest energy. If we add energy to that solid and it melts to become a liquid, that is higher energy. If we have that substance now as a liquid and we add more energy, it becomes a gas, and so forth and so on. So solids have the lowest energy. They're vibrating in place. Liquids have the second most energy. They're now free to move around each other. Gases are the higher energy state for a given substance. They're now allowed to move independently away from each other. Plasma would be the highest energy state. We're going to end this video here, and when we come back, we will look at the energy changes in order to get substances to go from a solid to a liquid to a gas to a plasma, and then back again as we would remove energy. And we will look at the phase changes, the names of the phase changes as they go from solids, liquids to gases, and plasma.